And we're back. Hope you missed us. Welcome to our third episode of All in the Field, AWS Agriculture Live.
In our last episode, we talked with two startups. One was Hector, and they talked about using computer vision in orchards. And so today we're going to talk about computer vision, Amazon Rekognition custom labels. We'll talk about ground truth, and we'll talk about HIT, which is not high intensity interval training. In this case, it is human intelligence tasks. So it should be a fun computer vision based episode for agriculture.
So let's jump into it. Welcome to All in the Field, AWS Agriculture Live.
Thanks for joining us again today. I'm Karen Hildebrand. I'm the worldwide tech leader for agriculture and an AI/ML doctor. But I'm based in Minnesota, and I'm a fourth generation farmer. And I'm really excited today because it is an episode about computer vision, but it's also an anomaly episode. And maybe this is our RBG moment, but we happen to have 4 women today that are on our show, and we know that that's an anomaly in agriculture and an anomaly in technology overall. And so we're really excited to have this opportunity. You know, I'm raising 2 sons, and so we definitely want to represent diversity and all that good stuff, both from, you know, where you are, from gender and country of origin. But we wanted to acknowledge that we have a pretty diverse group in front of you today. And so we hope that this is inspiring for all of those little girls that are behind their keyboards or out on the farm. So thanks again for coming on and sharing your time with us today. And we hope you enjoy our special guests. Rachel?
Yeah, that's right. And I'm with you as someone who has a son as well, you know, and I want to raise them to have the characteristics that we see so commonly in agriculture, right, across farmers and really any employee in the agriculture industry. You know, we want our sons to be strong and hardworking and independent and an advocate for agriculture and also an advocate for technological advancements. But as someone who has a daughter also and another daughter on the way, I want the same thing for my little girls. And historically speaking, you just don't see the same female role models in the industry. But I do think the tides are turning, which makes me super excited for today's episode. And I'm excited to jump in. Should probably introduce myself really quick. I'm Rachel Bradshaw. I'm a go-to-market specialist for IoT and agriculture based in Seattle, Washington. I'm an agriculture fanatic and also a IoT advocate. So with that, why don't we go ahead and jump into our field notes for the episode?
Sounds good. Well, we've talked about this before. There's so many applications for computer vision in agriculture. And we really just wanted to share, as we were kind of talking back and forth in preparation for this episode, kind of a couple common use cases that we're seeing, just to spark some ideas and thought processes before we start talking about actual services. So Rachel, why don't you kick us off?
Yeah, I mean, computer vision is really everywhere and it helps you see things even the human eye can't necessarily see. One example is working with customers where they're monitoring livestock in a facility, whether it be chickens or pigs, just monitoring the health by using computer vision to identify whether something goes awry. And really what it comes down to is SageMaker, those machine learning models that can recognize when something is out of whack and identify and alert someone to do something about it before it worsens or spreads to the rest of the group, the herd, or whatever it may be, depending on the animal.
Yeah, and I think that's so true, especially like even in with some of the animals as you're loading them onto transport trailers, there's so many things that you as a human have to be paying attention to just to have computer vision as an assist. Like one of the projects we've seen is just counting the livestock as they're loaded onto the trailer, so you know exactly how many. And I know, you know, chasing cattle onto a trailer myself, that it's hard to keep track of everything at the same time. But you know, cattle are big. Like even when we look at pigs and we're thinking about them, they're kind of squirrely. They go in multiple directions. And so when you're thinking about, you know, from a computer vision standpoint, you know, originally when you're building your bounding boxes, you might be thinking, yep, I'm going to bound around the whole pig. And what we've been learning is even just bounding the head helps us to understand that you're actually, which direction the pig is moving. Like, is it actually going onto the trailer or did it turn around? And so that way you're counting only those that are loaded. So it's kind of unique in thinking about how those bounding boxes can be applied.
It's so true. I actually spent some time on a pig farm, you know this, Karen, and I tried manually counting the pigs. There were three of us doing it, and we got three different numbers. So I think you're spot on there. But not just with animals, right? When you think about agriculture equipment manufacturers that are tracking different parts that go across the line and relying on humans to be able to identify and piece all the parts together and track and count, it can be really challenging. And that's where something like Amazon Rekognition custom labels can really assist. So I'm excited that we're talking about that later today in this episode.
Yeah, absolutely. And I know we talked even in our last episode with Hector and how they were talking about doing shape sorting and sizing of the apples as they were going into different bins. And the same thing can be done even with color sorting. So thinking about your, separating the greens, really being able to take and detect those types of small problems, but at scale, quite large problems to be able to solve. So that'll actually kind of may take us into describing, sometimes call the three-layer, or in advance of this topic episode, we actually have chats about how this is similar to, and whether you're going to get your butter from the store, or if you're going to be all the way at the bottom layer of the cake and your milk cow churning your butter and putting. So at that bottom layer, you're actually in the framework. So you are working at the base layer of machine learning, and you're able to take those frameworks like a TensorFlow, for example, and you may it out on an inferentia chip. If you move up to the next layer of the stack, that's kind of like if you're wanting to make butter, but you're not going to start actually by milking the cow. You're going to go a little bit further up the chain, and you're going to actually churn your own butter and put it on your toast. But in this case, you're using SageMaker, which is an IDE or an integrated development environment, and you're able to actually leverage a number of features that are pre-built. So we'll talk a little bit about ground truth today, but there's a number of other capabilities very similar to your notebook experience. And then if you go up to the top layer of the stack, it's like going to the grocery store and buying your butter. It's already AI manages, so they're pre-built and they're available for you to train on and customize, but they help you to get started more quickly. So thinking about that, that's really one of the ways that Rekognition custom labels works. And so we'll be diving in today's episode as well.
Yeah, that was a great lead in and a great analogy to use. And of course, as you know, because I always have to bring it back to IoT, we are not focused on IoT today, but I do want to point out that computers are at the core of what we're talking about today with computer vision, which really is just another device, right? You need to be able to capture a corpus of images at the edge, and you can then deploy machine learning models out to the edge using machine learning inference on green grass, for example, and compressing your model with SageMaker Neo. Again, not deep diving in that today, but want you to keep it in mind as we go through the next two guest hosts, the interviews rather. So with that, let's bring on our first guest host. Super excited to welcome Anushree Mainthia, AWS Senior Product Manager for Amazon Rekognition Custom Labels. Welcome to the show.
Hi, Rachel. Hi, Karen. It's so great to be here. I'm really excited. I am, in fact, a product manager for Amazon Rekognition, and specifically, I'm the product lead for Amazon Rekognition Custom Labels, which super excited to share more details about today. I have not chased cattle up onto a truck or counted pigs, I must admit, but I did grow up with a plethora of fruit trees in our backyard, and it's living in Southern California, it's kind of perfect for it. And I remember the joy of being able to pick a nectarine right off the tree and have all the juice just running down your face and barrels of nectarines kind of every summer. So there's definitely really happy memories for me around food and the importance of really fresh produce in our lives.
That's such a great story. I wish that I would have had that growing up. I can't say that fresh fruit ever grew in my backyard in Canada, certainly not nectarines. So that sounds pretty great. So how about before we get talking about Amazon Rekognition goals, could you just start us and base layer us with what is Amazon Rekognition?
Absolutely. I think if we go back to that magical 3-layer AI/ML cake, I think it's going to get pulled up in just a second. Essentially, Rekognition sits at that top layer. So it's like going to the store and buying that butter. And what Rekognition is a deep learning based image and video analysis service. And so with these easy to use, fully managed APIs that a developer can use, you guys can build AI ML capabilities into your applications using the APIs and using a set of SDKs that are available in lots of different programming languages. So depending on what's your favorite, it makes it even easier to use those APIs. And the great part about that AI services level, and Rachel and Karen, you talked about this a little bit, is because it's at that top layer, it's a managed service, Rekognition takes care of the heavy lifting around developing, training, building the ML models, and deploying them in highly available and highly scalable environments for our customers to be able to use. So that's Rekognition and where it sits. If we double click into Rekognition, there are a number of features within this image and video based ML based service. And that includes things from a content moderation API, which helps our customers identify potentially unsafe content and remove it before it hits a potential customer. Or a celebrity recognition API, which can pull from a catalog of hundreds of thousands of celebrities. Here we have Werner, to text and image and video. And some of our customers often analyze images of races. So imagine being able to pull bib numbers off of someone racing and being able to track them through a race, whether it's a 10K or a marathon. Diving into that first feature up there with our labels feature, this is something that allows developers to access deep learning-based image recognition for thousands of different objects, scenes, and concepts, all with that simple API. So rather than me talking about it more, it might be fun to see it in action. And with the Rekognition console, you can actually demo each of these pre-trained APIs. So let's get started for labels. So we're going to start with the demo, and Karen actually sent me 2 images in advance. So here you can see that we already have some preloaded, but we're going to pull in this one, and it's a dog in a field. And so what you'll be able to see is that Rekognition not only could identify a bounding box around the dog, but also concepts like field, grass, grassland, nature, that kind of thing. We're going to pull in a second image, and this one's more fun. Karen, I think you visited a vet clinic. And here you can see that Rekognition identifies not only the person and puts a bounding box around it, and we just talked about bounding boxes earlier, but also identifies the cow and puts a bounding box around that, in addition to labels at the image level. What we haven't expanded here, but as part of the API response, in addition to the labels, confidence, and bounding boxes for common objects, we also return, or labels also returns hierarchy. So you'll be able to see if, in this example, cow or cattle is clearly a child of mammal or animal, and you'll be able to see that, which can help with filtering.
That's great. And so Amazon Rekognition custom labels went GA in December of last year. So maybe you could just give us a 30-second breakdown of what custom labels is?
Yeah, absolutely. So we just walked through labels, and it's pretty powerful, right? At your fingertips or via the CLI and API command, you have the ability to access thousands of different objects and scenes, and you don't have to know anything about your image or video in advance. And that's, again, our customers have told us that this is super powerful, but the biggest feedback we've gotten is, I love labels, but it's not specific enough. For my use case, I'm looking for very particular things. And so let's look at an example to bring that to life. So if you're an auto parts manufacturer, you will have these parts on your line, and say you want to identify them. If you were to run them through a pre-trained API, you likely would get machine part or auto part. But what really matters for these customers is the specificity, right? You need to know, is it a turbocharger? Is it a torque converter? Is it a crankshaft? And so that's what customers are telling us, that they need that specificity. Another example is logos or brands. Sometimes in this specific example, you could imagine if you're a distributor as opposed to a manufacturer, you actually need to keep track of all the different brands and vendors you have, and being able to identify those logos on the parts themselves becomes really important. But you can't guarantee they'll be in a pre-trained API. You need to make sure that it has the ones you're looking for. And that's where the power of being able to customize comes into play. The challenge is to do this yourself, it takes a lot of time. So customers, if the pre-trained APIs don't work, customers can build it themselves. But that takes tens of thousands of images. That takes a lot of time. And you have to know why, for example, the Amazon logo is really easy to train versus the Nike logo is really hard to train. You have to know ML. The other alternatives is you could do it manually, but again, that's super time consuming and it doesn't really scale in a way, especially when you hit high volumes. So that's why we created custom labels. So imagine if you could take all of the power of Rekognition, all of the investments that we've made in science, the algorithms and the techniques, and you could customize them by bringing your own data, BYOD. And so that's what custom labels lets you do. You bring your data, which is your specific use case. Here, it would be the different auto parts, and you label them. You identify this is a turbocharger, this is a torque converter, this is a crankshaft. And custom labels will take that data. It'll use it to train a custom model for you that only you can access, that is customized to your use case. And you can do it, and by the way, here's my favorite part. You can do it with as few as 10 images, right? We're going from hundreds of thousands to train a model to 10 to start. And you can create a fully functional production model without writing a single line of code. Let's bring up a specific example. This was another image you gave me, Karen. So here, there's lots of fun ways that you can actually use the different pre-trained APIs in addition to custom labels. So in this example, labels, our pre-trained API did a great job of actually locating the calves in the image. But you can imagine a use case where you actually need to identify the ear tag. And so you can train a custom model to identify various ear tags that may be different based on animal, based on farm, based on location. And also you can use text and image to then read that label, right? If it's in the right angle and the visibility, you can then build a workflow where you use text and image to read the actual number and potentially track the pigs that you're loading onto a truck more effectively, or calves in this case.
I've heard of BYOD, but never BYOD. So that was I like that one.
That's right. That's right. This all sounds super interesting, Anushree, but is this more art of the possible, or are you seeing this in real life use cases? Can you break it down on the use cases that you're actually seeing today from customers?
Yeah, totally. And this isn't art of the possible. I think our goal was to make this something that is a tool. It's something that, yes, you can do it quickly. Yes, you can start small. But the minute your model is trained, you can do scalable inference, millions, hundreds of millions of images. It operates at the scale and operational excellence that AWS does. Some really fun examples that we're seeing of use cases, and really custom labels has such a wide variety. I know there's a rule of 3, but hopefully you guys will let me do 4 or 5 examples. First is within, media entertainment. We're all watching a lot of online content in the current environment. Think about a customer who can train for specific animated characters or objects that are proprietary IP, and then be able to find it in archive content and surface that more quickly. So they can create highlight reels, clips, more content kind of effectively. And character logos are notoriously challenging and require tens of thousands, even more than that, in terms of getting those right. We also have customers training on specific brands and logos. I mentioned that a little bit earlier, but the use case there is around either brand compliance. Is my brand being used in the right way? Or sponsorship analysis. How much of the screen is a logo taking? What's the share of voice there? So there's a lot of rich analysis that can be done on the marketing side for that. We've certainly had customers train on products to ensure display compliance. Are all my products displayed right? We know that sometimes there's a fight for shelf space. So are all the products in the right place? Is everything that should be there? Is there stuff that shouldn't be there? But you can train on the specific products you care about. In industrial and manufacturing, we hear, customers are using it for process automation, visual inspection, QA, preventative maintenance, automating field audits. And then finally, to bring it back to agriculture, and a fun one, in addition to the industrial and manufacturing use cases, with agriculture customers specifically, we often see things around crop health, phases of crop development. In this case, these are cucumber leaves, and a pre-trained model would identify them as leaves. But if it's your farm and it's your cucumber farm, you want to know, are these damaged, infected, healthy? What is the health of your crop? And even for weed identification, what type of weed it is. So those are some of the really fun use cases that we're hearing about. Custom labels it's a really flexible platform, which is why it's such a broad range. But that's what makes it more exciting.
And I think that is what makes it more exciting, because really what we want to talk about is, how do people get started? Like, you've shown a really broad array of use cases, and we'll let you keep going because this is what we're here for. We want people to be able to get started and understand, like, technically, is this possible? I think, to build on Rachel's question, like, I think one of the biggest things we get is, that's really cool, you guys can do that, but could I really do that? And so could you maybe, talk us through the flow of how you get started?
Yeah, absolutely. So, earlier I mentioned you can do it without a single line of code. So let's take it that way. And in part, we did that so our customers could spend more time thinking about their use case and less time having to build something from scratch and debugging and iterating. So let's say we want to find, and you guys gave me this idea, so I'm not going to take credit for it. But say you want to create a model to find worms on a plant stock. And so once you're in the custom labels platform, the first thing you're going to do is you're going to create a project. And the project essentially is your container for the iterative model versions you have and your training test data sets performance. The first phase of creating a model is creating a data set. That's the data that's going to train your model. It's labeled images. In this case, we're going to actually pull things in from the desktop. But you can also, if you already have an annotated data set in ground truth, for example, you can point us to that manifest. Once you create your data set, you'll open into a gallery view and you'll drag and drop those images. So here there are 12 images that are being dragged and dropped into the console. We'll do a few quick checks to make sure that they're the right size. And then once everything is set in terms of the images, the first thing you do is you say, what am I actually trying to find? So you'll add your labels. And in this case, we want to find the Bertha armyworms. So you're going to add that in. Custom labels support single class object detection. So all you need to do is add one. And then you go through and, here we're clicking on each image and drawing bounding boxes around the worm. And that's because we care about the localization of that worm. But if you were looking at something at the image level, you wanted concepts or scenes, you could actually do that as well in this user interface where you can actually pick the assign label, and that'll do it at the image level as well. The great part is you don't actually have to tell custom labels anything up front, because what it's going to do is it's going to look at your annotations in your test and train data set and then figure out what you were doing. Right? We know if you gave us bounding boxes that you want a localization model. And so that's what will be generated at the outset. You don't actually have to know what that is before you even start. You just need to know your problem. I want to find these worms on these plants and where they are. So one quick pro tip here is if you want to select multiple, you just hit the shift button. Otherwise you don't have to click all 9. So that's a fun little one. But once you've saved all your changes and you've labeled all your images, you're ready to go. The one thing that I would say is custom labels does require a test set. And we actually recommend creating a separate one because that can be like the final exam at the end of a semester. It's how we evaluate how good your model is. And if you have the same test set from model version to model version, you can compare, but you don't have to, right? So you can actually, as part of when you hit that button train, there's going to be a big orange button, the way that in all Amazon consoles there are. You're going to hit train, and then you're going to be given a few options where you'll just put in your training set, and you can actually choose to auto split. And in that case, we'll just hold back 20% of your data set that you just created and use that to test. It won't ever be used to train. So that way it's not cheating. Once your model's trained, the console has detailed evaluation metrics. So you'll get, for those familiar with ML and AI, it'll be your F1 score, precision, recall, and that'll be at the aggregate and label level. But as I mentioned, this is a fully functioning production-ready model. So you can use the APIs or via the SDKs to start, detect, and stop immediately after training is complete.
Oh, very cool. So some of our customers have use cases for wildlife and trail cameras that are already ruggedized for rural or remote environments. Can custom labels be used for those cases?
Yeah, definitely. I actually think it's a great example because at least in the scenarios that we've heard about, those images are already being sent to the cloud, so there's access there. And in custom labels, we recommend that you train on what your production is going to be. And on those, via those trail cameras, there's often different lighting conditions. There's different things that are obscuring the field of view. There's daytime, nighttime, rainy, sunny, and you're looking for different things. And they may look very specific based on that image. So again, in this case, it's pretty simple. And if I sound like a broken record, it's probably because I actually think this is pretty cool. But you can look at what's in your cloud account and the set of images that have been taken. Start with a handful of those, annotate them in the console, or you can use ground truth if you're looking at a lot more, and get a first version of your model up and running. And then you can use that to analyze all the other images as part of those trail cams. And it's going to be customized to that use case because it's using those images to train. So it's already been tuned to the environment, the location, the level of clarity of the image, all those kind of things. The one last point that I would note, because I know this comes up a lot, is with custom labels, the model is our customers. It's only your model. No one else has access to it. You decide who has access to it. So anything that you train or do or improve stays with you, and you decide how you use that. So it's one of those really important parts.
Yeah, I think that's a really good call out. I think that privacy is really important to when you're using these AI managed services. So that's great for you to mention. So like, I have to say, there's been so much fun prepping for this episode, like actually making my own models and using custom labels. And, every time I see you do something, I'm like, oh, I want to build that as a model. So when you're doing the parts, I was like, oh, I wonder if that would work when like I broke a belt last year on the combine and I didn't know how to like describe which one it was, whether I could like in the future be able to do that. So when I'm thinking of like, okay, I have the question, can I build this model or not? How do I know? Like, should I just try, or like what would be your kind of rule of thumb?
Yeah. So in most cases, it'll be just try. The rule of thumb that we use is if a human can identify it just from the image alone, so no other cues in a couple seconds, there's probably a pretty good chance that you could train a model to do that too. And so again, that's where I'd say try it, right? If you could identify what belt that was from the image, or at least identify that it was a belt, and that gets you half of the way there, then you should absolutely try.
Somebody else knows how to do that?
Exactly.
Okay.
The other great part, and this is what I love about AWS, is in addition to it being really easy to start with as few as 10 images, and you can do that in under an hour, as both you and I have done several times before calls and in prep for this, I think I have way more models trained now than I did before. There's a lot of resources kind of at the disposal of our customers, whether it's our documentation, premium support, our AWS team in the technical field like yourself, who always know how to get a hold of us from the service side. But there's a lot of help out there, and we're super interested to hear about these really interesting and cool use cases and help solve some of these problems.
Very cool. Now, I have to ask, because you mentioned this earlier about getting started with 10 images. And I have to ask because I know our customers are going to ask, 10 images? Come on. Is that all you need to get started, is 10 images?
Yeah. I know it sounds really small, but I think that's what the most exciting part is data sets are often the hardest part of any ML process, right? If you talk to any ML scientist, there's often a lot of work that goes into creating that data set, and you're talking about tens of thousands of images. That is a undertaking in and of itself. So we've optimized some of our algorithm techniques under the hood to ensure that you can start small, right? And it's why we thought about that, because we didn't want that to be a stopping mechanism or a blocking mechanism to get to that first version of your model. We also, really encourage iteratively improving your model. So start with 10 images. And then Nathan is going to post in the chat a link to a feedback solution. But essentially, I'll describe the workflow briefly. You start with 10 images and you train a version of your model. Instead of then annotating or labeling 100 more images, use your model to do a first pass of predictions. It's much easier to correct something than it is to start from scratch. And so that solution will kick off a ground truth verification job where you can say, yes, you got it right, or no, you got it wrong. Here's the right thing. Think about a grading and exam. And then that solution will recollapse that back into a manifest format that you can ingest and retrain. And so what that does is it lets you go from 10 images to 50 images to 100 to 500 to a model that you feel comfortable with. And even after you get to production, using either the same feedback solution or A2I human in the loop, you can continuously improve your model, because we think that iterative improvement is super important to kind of handle all of the use cases. The one last note that I would say on data sets, and this is a slight rule of thumb, is in terms of the number of samples you need, it's often good to think about how hard your problem is. So if it's a really straightforward problem and you're going to have, it looks like X and I'm going to find X, then you probably need a really small set of images. But if you're talking about really minute differences, the example I often bring up is the difference between a gerbil and a hamster. They look awfully similar. you'll probably need a few more examples there because those differences are very fine-grained differences. And so the size of your data set often depends on the complexity of your problem.
No, I love that so much because when we speak with customers, a lot of times it does seem overwhelming to start with computer vision because they think they need this large corpus of images. But based on what you're telling us today, you really just need to get started with a few. 10 is very little, which makes it seem easy to get started.
Yep,
Yeah,
exactly.
I am pivoting over since you already called out Nathan and Matt, who are our moderators, because they already have a question in here. And you've already answered one of the questions, which is really just, is there a minimum number of images needed to upload to create your data set? And I think you said, even minor of 10, and then, try it, right? And see what that looks like. Now you did, there's one more question that just came in from, oh, geez, I am terrible with handles. Joa Bowie. But anyway, hopefully that's close enough. Can it work?
Sorry.
Labels on videos.
So right now, custom labels is image-based. So you'll train on images and it runs inference on images. We have a code snippet in our documentation around some FFmpeg code that can help you frame extract. And we are thinking about video. It certainly is something that we would like, we think makes sense as a natural in terms of image and video analysis.
I love it. And I love that we're always customer obsessed and taking their feedback and making those part of our features. So that I'm going to take that as our transition to say, thank you so much for your time today. You mentioned we have the access to be able to talk to you anytime. As a tech leader, I totally appreciate your being on the show today. And thanks for joining us. So we'll see you in probably a week. But nice to talk to you, Nancy.
Thanks so much. It was great to be here. Thanks, guys.
Thanks. And with that, let's bring on our next lady guest host, which I'm super excited about. Jen Kang, come on down.
I feel like we're in a game show there.
I know. Jen is it does sound like a game show. Jen Kang is our AWS Analytics ML practice lead. Jen, why don't you introduce yourself?
Hi, guys. Thank you so much. So, today I actually was just thinking about what actually connects me to agriculture, right? So my husband grew up in a farm in Montana, and every Christmas visit, I really have no topic I can discuss with the families and, folks in Montana and kids. But, I start talking about agriculture topic and they're listening to me during the Christmas dinners and whatnot. And I'm like, okay, this gives me a reason. And then I dug deeper, and then I find out that there's all this historical data from Agriculture Agency that, there's abundant of data that just got me really interested in agriculture. And that's actually why I'm here today. So I'm really excited. Thank you.
Yeah, no, we're really glad to have you here. Being part of our ProServe team, when customers are talking with us in solutions architecture, it's before they, necessarily know exactly what it is they want to build. And so, or they're looking for ideas. And the ProServe side of the world, you're actually in with our customers every day, solving problems and hands in there and figuring it out. So we have been trying really hard to convert you to just be a complete Aggie, but we know that you're just an ML ninja overall. So we're going to throw all kinds of questions at you today, so fair game, sorry. But we hope that you cover a wide spectrum of the customers that you're working with.
Absolutely. So I think that, one of the reasons I actually kind of became super interested in this is because, as you're looking into agriculture problem, it's really fascinating. You have so many different variables. You actually get to have, the varying degree of changing weather conditions, right? Whether it's going to be thunderstorm, rainy or sunny, but now really windy. And now think about potato farms, and it has to be perfect wind gust to spray the pesticides for the 10-minute window, right? Or the lettuce, to be transported in a perfect temperature from different supply chain 24 hours prior for your consumption in supermarket aisle. These problems are really tough to solve, but really fun, right? And there's so much data readily available publicly for you to use.
Right. No, you're spot on. And we started this episode talking about Rekognition and custom labels, which is, in our managed service layer of our AI ML tier cake, for lack of a better term. But if we move down into the IDE tier, we have SageMaker, which has been around since November 2017. Now, can we explain just at a high level elevator pitch what SageMaker is before we break down custom labels? How does SageMaker help me become an ML master, or at least look like an ML master?
Sure, there's so many tricks. So essentially, the best way to think about this is that SageMaker is a managed service that really gets you get going from start to finish. Anushri already mentioned this already. You start with the labeling, you prepare your data, you choose an algorithm, and then you train and tune and optimize for deployment, and you make predictions. So think of yourself like if you're a developer without modeling skill, you can start training with an API call on a single or cluster of instances using pre-built algorithms, right? You don't have to actually build a model. Everything, including algorithm selection, hyperparameter tuning, is automated. If you're a data scientist and you really have no engineering skills, using SageMaker is actually going to rock your world because it's there. You don't have to worry about it. And you, having done this by myself, the biggest benefit really was that SageMaker provision environment for me, that everything is installed out of box and you have access to cutting edge GPUs for training and inference. It makes your job easier. Like if you're to do this for yourself, installing various software packages itself is really time consuming for no value. You get this ping where you actually completed 12 hours after that. And then you go, well, this is not compatible version. Trying to actually install this Python. And then you have to start over again. You don't know exactly what's compatible. Does that give you understanding, Rachel?
No, that was great. Thanks, Jen.
Yeah, so now that we kind of have an idea of what SageMaker is, can you maybe describe for us how ground truth plays into that kind of middle tier of the cake and how that helps with SageMaker?
Sure. So Karen, let me take a step back. You know that there are supervised and unsupervised training, right? So think of us, like all of us when we're a baby, our parents taught us words. And then they oftentimes, show the picture card, right? Here's a watermelon, here's the picture of watermelon. And then the baby toddler looks at the card and starts associating the image with the word. Moms and dads later on actually make associations and then reinforces the learning, right? And then the baby learns. In this scenario, a label is provided for a toddler to infer, and this is an effective way to learn. Now, you have an input, you validate the data, and you produce an output. A majority of machine learning really belongs to supervised and semi-supervised, and it's not humanly possible to label millions of records. In computer vision, labeling the data is challenging both in granularity and label. Is it just bounding boxes or each pixel in the bounding box that needs to be labeled? Ground truth really offers easy access to human labelers for common labeling tests. Underneath the cover, there is a machine learning model behind that labels raw data to pre-data sets, and data is only routed to humans if the active learning model cannot confidently label it. For example, we're working with a pharmaceutical company using computer vision to do kidney injury assessment for clinical trials. The data sets were diabetic study of mice kidneys, and these are not visible into your naked eyes, right? These are tiny, tiny cell that's visible only through microscopic lens in a specialized equipment. And the objects are categorized into one of the classes in the predefined collection. And that would actually kind of give you understanding of the ground truth and what it does.
Well, that's super cool, especially when we talk to customers that are dealing with pests and insects in their fields and crops. So being able to go that small is fantastic and I think very useful. So there are 4 pre-built ground truth models, right? There's image classification, single or multi-label, bounding box, or semantic segmentation, and label verification, right? And in agriculture, there are a lot of different use cases, but if we choose something like counting livestock, as we were talking about earlier, for example, if I'm vaccinating my cattle, how many cattle went through the head gate or loaded onto the transport I could use? Could I use image or video, or rather I could use image or video. Are there other use cases you've worked with where ground truth would make sense?
Yeah, absolutely. So I think that, let me give you a bounding box and multi-label example that can be applied on produce inventory check in outdoor space with a light variance. So just imagine yourself, stopping by a gas station in the summertime to get the ice cream to cool off. Now you remember those, ice cream fridge where the glass is on top and you slide on top, right? And remember, like the gas station owners always want to have, want to check how many ice cream do I have in that box at any given time because they don't have a storage, but they actually want to order enough. Now, using this, on your right, you're actually seeing how you can actually follow through the instruction of what you select in order to actually get to the bounding box, is that, you are looking at, creating a bounding box for the ice creams, but there is a variation of the light reflection of the cameras depending on what daytime that you're looking at, right? You could be much brighter in the sunlight of the daytime versus a lot shadow in the afternoon and evening time. So looking at all of this light exposure reflection on top, you're actually creating multiple labels, and maybe it's the same object, but nonetheless, ice cream assortment also changes constantly because people are purchasing, right? And you want to capture that in real time. So then essentially you're looking at combining bounding box around each ice cream and then multi-labeling them and labeling verification to create labels to understand how many ice creams you would have at any given time. And this totally is applicable to exactly the cattle case that you just mentioned earlier, Rachel.
No, I agree, because I think that for the human eye, a lot of us can look at a cow and know it's different than a pig. But when you're looking at a whole herd, you can't necessarily tell which one is which. And so it does sound like it's applicable. Thank you.
Yeah, and I know, Jen, we've been talking about kind of use case push the realm of possible. Like we talked a little bit earlier with Anushree of how easy it is to get started. I also know that we're also working on some pretty cutting edge. I know we were talking a little bit about how to do that image processing out on the edge, and you were sharing a little bit about quick service restaurants. So do you mind just sharing that with everybody today? Because I think it was really fascinating.
Sure. So just to think about for a kitchen operation in restaurants, automating tracking process is crucial as it reduces human labor and has a potential to increase accuracy, right? If you're selling burgers, how many burgers and how many patties do you have at any given time will actually give you better ability to forecast and meet that demand that your customers have. So to capture the inventory real time, there was a live video feed with 3 camera angles, and we applied transfer learning on MXNet and forgetting factor logic to achieve a memory adaptive window. It's really important to do that because otherwise it may actually not recognize that, it's the same patties that you actually saw, but then you need to follow through that, right? So essentially using this, we detected and tracked 10 food items and 5 utensil items in real time, which was about, 0.8 seconds per frame, right? Constant real time, camera monitoring. So people are working on it. Art of Possible is happening today.
Anyone else planning on getting burgers after the show? Just
I think that's the pregnant lady speaking. I'm sorry, Rachel.
Yeah.
We tortured you there.
So Jen, I do have another question for you. And we've mentioned this a little bit already earlier, and that is using computer vision for plant health monitoring. And in order to do this, you need models that are able to identify different phases of plant health. And for different plants, that can actually be really challenging when you're using even just a human eye. But when it comes to computer vision, how does that work? Can you explain how this works with object detection capability with ground truth in plants?
Sure. Yeah. So, let me just kind of give you an example. So, for example, almond trees blossom in February, right? It's a very seasonal thing. And it's a highly seasonal, and during the limited harvest time, it's grower's best interest to maximize the cycle. If you're pointing the camera on almond trees over a year, you detect blossom in the tree in February. Scaling in computer vision is not an easy task. If you look at the tree from 5 feet away versus 20 feet away, it might be the same tree and same condition of blossom, but an algorithm might recognize it as a different. In order to solve it, you need to understand a trade-off between size or count of blossom. It's about how you process the output. If they're going to focus on size, the steps of modeling is to detect blooming location given an image. We calculate the size of blooming by calculating size of pixels and counting threshold. In general, labeling the data is tough with a computer vision. And, so in order to actually compensate for that, you actually want to be thinking about clear trade-off and then focusing on that each step along the way, right?
Yeah, that absolutely makes sense. And we actually covered all 3 tiers of the stack today. And so we talked a little bit about custom labels as part of Amazon Rekognition. We've talked about SageMaker and using ground truth, and then you went all the way down to the framework level there. So that's a really good point for us to see if there's actually some additional questions, because I see my chat screen off to the side here, always out of the corner of my eye, and there's a number that came in. So I'm terrible at this, Rachel. Do you want to take some of these handles? I'm terrible.
Oh,
I'm trying NAFITS 949. Would technology be applicable for wildlife conservancy? For example, trap camera data.
Yeah, so I think that if you're actually looking at the camera data, I'm assuming that you guys already have a camera in it, right? And you're actually collecting information. This will be probably edge ML, machine learning edge, right? But nonetheless, yes, just like how we explained this, right? You actually do apply the same technique and same labeling understanding. Anything moving on, so video is a little tough, but you actually have a sequence to get to that. But start with the still images and then get to that video part as a second. Hopefully that answered the question.
I think so.
Right,
one more question?
Yeah, I think so. So Alex Masha? Oh, I am terrible. You guys are you can actually like type in how terribly I do with your handles. So your pricing for this is based on total number of objects instead of the numbers of users allocated to the labeling job.
The pricing itself is actually like so a fraction of the price. I wouldn't even worry about that at this point. Whatever that you have images going on, just get into the SageMaker, get into the ground truth and start experimenting. Most of it actually is offered for free. Start experimenting. The pricing actually guideline is published publicly. But don't worry about that too much until you actually know what you're going to do first.
I think that's a great answer, because it also depends on what region you're running in and which part of the process you're in, whether you're in the build and the train or if you're in inference. So I think that was terrific. All right.
That was a good answer.
Well, Jen, thanks today. We really appreciate your joining our Twitch stream. It's always great to see you, and thanks for taking the time.
Thanks so much, Jen. And now it's time to move into one of my favorite segments personally, and that is all the tricks. Karen, what do you have for us today?
I feel like I have to say cool things like that. So I went in and made a demo that is particular to labeling. And so our tip is all around the labelers who are available and who can be for assistive labeling. And so in culture, there's lots of experts who can, and there is an entire winter season, obviously in different months, depending where you are in the world. But there's a whole people that can be labeling, whether that be your agronomist or if that is somebody in the barn manager, or maybe it's your next generation that's out there farming simulator, have labeling your images. No, serious. There are a couple of options in the console. You can see there was mechanic, which is basically your human intelligence tasks. That's a way that you can outsource that. You can also label them with your own workforce, or in this case, and you'll notice because I'm an internal account right now, of course, that you can actually use a third-party service through the AWS marketplace. And in this case, I specifically said Cogito, but really the key tip is if you need to label your images, there is a number of different labeling workforces out there. So don't let that be a barrier to trying. Start small if you need. Leverage labelers if you need. But really, if somebody on your team wants to get started with computer vision, or you want to get started with computer vision, reach out to your AWS SA. If you can't find your AWS SA, reach out to Rachel and I directly, our awesome moderators that are here on the side throwing questions at us. Nathan and Matt, feel free to reach out. Don't let there be barriers to getting started.
So the biggest tip you're saying is to just try. That's the biggest tip of the day.
I kind of feel like I say that to my kids all the time, but yes, the biggest tip is just try.
No, I agree 100%. As we talked about earlier, sometimes the hardest part is just getting started. But as we heard today, you don't need a lot of images to get started. You don't need a lot to get started in general. There's free tiers. So hopefully you're learning that. Go in, give it a shot, and let us know if you have questions. So with that, let's go ahead and jump to the Make an Impact Challenge. And today we're actually going to be talking about winners, which is always exciting. So if you recall in our first episode, we talked about a geospatial hackathon that was put on by 1904 Labs. And the focus was on food distribution. With the ongoing pandemic, we've realized that it has exposed the fragility of food distribution channels, and this has resulted in viable goods sitting to spoil while consumers deal with shortages. And those taking part in this challenge, there was both a competitive effort and a collaborative effort. So we focused on the collaborative effort of the hackathon. And so those taking part were focused on the collaborative effort and what was called the Plan B, when elements, not elephants, of the traditional food distribution network break down. And the Pro Division first place winner was the Bayer team. Bayer's hackathon team wanted to build a visualization web GSI platform that provides users with a way to explore trends. They collected a variety of data sources related to COVID, including Twitter social network data, state-level COVID case data, and Facebook location data. So for Twitter data, they created a time ticker that represents the points of interest for users that tweeted something related to COVID in the previous week prior to the hackathon. And on their map, you can see where those points of interest are located. And it gives you a basic idea of where clusters are occurring to identify larger trends. And then for the state level data, they displayed state boundaries on their map that then the user can interact with within each state and see its case data. And the user can also open a chart to interact with the backend API that grabs data from a post-GIS database with data on COVID-19 positive and active cases over the past few months by each state. And these charts give the user historical information on how COVID is evolving in each state and a way to compare different regions. So super cool. Congratulations again to the Bayer team.
And awesome. And the first place in the college division was the Maryville Ethical Hackers team. And the MEH team focused on predicting events based on previous correlations. And they used both analysts and amateurs to monitor their ongoing trends here. And so the red dots represent COVID-19 with data from the New York Times repository, and the blue dots represent Twitter cases, Twitter data related to COVID, and then the green dots indicate keyword search. And so they used vaccine, actually, is what the green search term was now. And they also happened to be the recipient of the overall prize. And so we wanted to make sure that we showcase the results of the Make an Impact Challenge from previous episodes. So congratulations to the winners. And with that, we're going to wrap up today's show. If you want to connect with us after the show, tweet your questions or ideas to #AllInTheField.
Yeah, that's great. And I hope you all realize that Nathan's been sharing resources there in the chat. If you didn't, take a look at the chat stream. There should be links to a bunch of different content that you can look up on your own. Ideas for episodes, as Karen already mentioned, topics you want to talk about or want us to talk about rather, let us know at #AllInTheField. And thanks so much for joining us. And a special thank you to Anushri and Jen for spending time with us today. Again, I'm Rachel Bradshaw.
And I'm Karen Hildebrand. We look forward to seeing you again on October 15th. We are going to have 3 startup customers who are going to talk to us about how they solved for connectivity challenges. So that one will be really exciting too. So we hope that you'll join us then. And so that is all we have today for All in the Field.
I do have to say really quick, Karen, since next episode is about connectivity, I think this is our first episode where we didn't have connectivity problems, knock on wood. So super excited for our next episode. Hope you all can join us. Thanks again for joining All in the Field, AWS Agriculture Live.